Okay, so we continue the lesson of logarithms again, but today we switch the topic a little bit. We want to solve logarithmic and exponential equations. Yes, and as usual, you know what an equation is. Is an equality in which a variable is unknown. We want to determine all possible values for that variable so that it makes the equality right. Correct. Okay. So let us start with the simplest possible case. So if I give you 2 to the power of x equals to 4 and I ask you to find x, of course this is very simple. Yes, you already know what to do. So instead of 4 you can write 2 to the power of 2, and then you compare this one with that one, and then immediately you realize that x is what? 2, and that is the end of the solution. Okay, so I am talking about these kinds of equations. These kind of equations are different from these kinds of equations. Yes, this is called a polynomial equation or a quadratic equation because the variable is in the base and the exponent is a constant. This is the other way around. You see, still x is missing, so that's an equation. But this is different from that equation. In that equation, x, which is the variable, is in the base. The exponent is constant, but this is the other way around. What is in the base is constant. The variable that I am looking for is in the exponent. So these kinds of equations are called exponential equations, yes? Exponential equations. These kinds of equations are called polynomial equations. Of course, in this case, you can also consider it a quadratic equation because the degree is 2. But these kinds of equations are called polynomial equations. Polynomial equations are the equations in which the unknown is in the base. The exponential equations are equations in which the unknown is in the exponent. Yes?
What is it called if both the base and...
There's no name for it then. That function, for example, x to power x, has not a very particular name in mathematics. Okay, now, of course, this was so simple. But if I change the problem to 2 to the power of x equals to 5, and I ask you to solve it, this is the reason we learned about logarithm. So if I ask you what x is, so what do you say?
Logarithm of 5 over 2.
Base 2.
Base 2.
Yeah, so you say that x is what? Is logarithm of this number 5 base 2. Is that understandable for everyone? That was the definition of the logarithm in the first place. Why this is the case? Because if I ask you what is the meaning of this, you will tell me 2 to the x is 5, and that's exactly what I want. So this is very simple, you see. That's the answer. Okay? But there is an alternative way in the book. I want you to know about that. That's also good to know. So the book wants to solve this problem, solve this in that way. So it says that, okay, 2 to the x is equal to 5. It says that, okay, if this number is supposed to be equal to this number, then the logarithm of this number should also match with the logarithm of that number. Okay, so the book says that, okay, the log of 2 to the x is also equal to log of 5. So I want you to understand the logic. My goal is to isolate x. The book uses this method, which is also very good. So it says that, okay, I want to isolate x. I cannot get rid of 2 easily unless I take log. When I take log, the log of this becomes equal to log of that. I chose which base, for example? When I don't write the base, it means the base is 10. Of course, you could choose any other base you like, but the standard one is base 10, because at least you don't need to write 10. Okay, and then we learned something even before the break, and I reviewed this completely the previous lesson. What happens to this x, do you remember? If x is in this power, it goes back to the log, yes? So what happens? It becomes x times logarithm of 2 is equal to logarithm of 5. Yes? But now I want to isolate x. What is your suggestion?
Division.
You divide. Exactly. So you divide by this number, whatever that is. X becomes the right side is log of 5 divided by log of 2. And this is the answer given in the book. You might be a little bit surprised why the answers are different. And then if mathematics is going to work, the answers shouldn't be different. They have to be exactly the same numbers, okay? So that is a very nice formula. So let me check it using this GeoGebra to see how it works. This to you in the exam, if you write this answer, that's 100% correct. If you write that answer, it's also correct. My goal for you is to prove, I will prove it for you, even though it is not mentioned directly in the book. This number is equal to this number. It's a very nice formula, you see. If you have log of 5 to the base 2, you can write it as log of 5, whatever it is, divided by log of 2. For example, if I have log of a to the base b, if I want to, I can write it as log of what? A divided by log of b. And that is very important because usually if you have GeoGebra, of course, GeoGebra can calculate this directly. But if you have a calculator has only one button for log, only. So if you want to calculate this using a calculator, so you have to do what? You have to write log of 5 by calculator divided by log of 2. Yes?
Does this work if the base is anything other than 10?
Yes. So that is one particular case of what we call the base change formula. So for example, if you want log of 5 to, I can decide to go to base 7. Okay, so for example, I can write log of 5 to the base 7, but I have to divide by log of 2 to the same base 7. So it means that I jumped from base 2 to base 7. Here, this is not very common because then you have to write 7 here. It becomes a little bit ugly. So this formula is more compact. So in this case, that's correct. If you want, you can go from a, b, and then write it log of, for example, a to the base c, whatever you like. Of course, it should be you should have c should be positive and not equal to 1, because otherwise the base doesn't make sense here. And then you can go to log of b to the base c. So if you have any log to any base, if you want, you can switch the base to any other permissible actually base c. But the most common one is this one, that you jump to base 10. Okay, so my point is that let us not deviate a lot. If I give you this question in the exam and I ask you to solve this equation, if you write this, that's correct. But if you write this method, that's also correct. It's a little bit longer, but that's of course correct. But you might say that, okay, why these answers are the same? We can prove that they are the same. One way to prove it is this is the proof, yes? Because this is the same x. I calculated in two different ways. Once I got this answer, another time I got that answer. They have to be the same. So that's more or less the proof. But let us try to prove it once for all. My goal is to show that logarithm of a to the base b is equal to the logarithm of a divided by logarithm of b. It's an extremely useful formula. Why do you think this is the case? Okay, I don't know how much you remember from the previous lessons before the break. If you want to prove something about logarithm, it is better to give them a name. So for example, I would say let this logarithm a to the base b, let me call it m myself, and let logarithm of a, I call it n, and for example, logarithm of b, let me call it capital P. For example, you can give any name that you like. Okay, now I want to ask you, when you say logarithm of a to the base b is m, what is the conclusion coming out of it? What is the meaning? This one to this one should be equal to that. That's the mean, yes? So b to the m is equal to what? A. When you say logarithm of a is n, what is the meaning of this one?
to the power.
Yes, because the base is 10, 10 to the n becomes what? A. Yes. And then when you say logarithm of b is p, what does this mean? 10 to the p is what? Do you agree? Okay. Now, I go back here. Instead of b, I put this. And instead of a, I put this. Yes? So instead of b, I write 10 to the p. This is b. But on top of b, I have m is equal to. Instead of a, I can write 10 to the n. Yes? But do you remember a formula from Math 1C here? 10 to the p and then to the m again. 10 to what?
10 to PM.
Pm, yes. P times m is equal to 10 to the power of n. Now compare them. This is a power of 10. That is also a power of 10. They are supposed to be equal. This cannot happen unless what? The exponents are the same. So it means p multiplied by m is equal to n. And now I divide everything by m to isolate p. So what happens? Sorry. To divide everything by p. Yes, thank you. I divide everything by p to isolate m. If I divide everything by p, the left side becomes m, the right side becomes n over p. Do you agree? Okay, but what was m? Look, m was logarithm of a to the base b. What was n? N was logarithm of a. What was p? It was logarithm of b. So that is the general proof for this formula. But that's a very, very handy formula. For example, can you tell me immediately what is the answer to this? Logarithm of 2 to the base 3 multiplied by logarithm of 3 to the base 2. Yes?
Logarithm of 2 divided by logarithm.
No, final answer. You are calculating. That's correct. But what's the final answer? If you ask me, Babak, do you know logarithm of 2 to the base 3? I don't know. I have to use the calculator, and then the calculator will give me not exact value, approximate value, and the same thing here. But I know this number is exactly equal to
Is it 1?
Yes. Why is that? Because I just told you logarithm of 2 to the base 3 can be written in which way? I can write it as logarithm of 2 divided by logarithm of 3. It doesn't mean I know this. No, I don't know it. I don't know this, I don't know this, I don't know this, but I know something. I know whatever this is equal to this. And then multiplied by, what can I write for this one? Logarithm of 3 divided by logarithm of 2. I don't need to know them, because whatever this fraction is, that is the reciprocal of that fraction. Or in other words, this logarithm of 2, whatever it is, it cancels that logarithm 2 because they are the same. And this logarithm of 3 will cancel that one. So what's left? 1, 1, 1, 1. So the product is just 1. Okay? So this is good to remember. Okay? If I were you, I would write this. How many formulas we had up to yesterday? Do you remember? It was 6 formulas. 5, 5 prime, and 6. I would recommend you to write this as 7. But if you want to write it, you have to write it in this way. A should be positive. B should be positive. B shouldn't be equal to 1. So I would recommend you to add this to your list of formulas, and that is the end of the story. Okay, so now let us go back to the main topic here, solving equations. I want to make the equations a little bit harder, but you need to face 2 types of equations. An equation which is called exponential equation. Another type of equations is called logarithmic equations. Okay, so what is logarithmic equations now? Logarithmic equations is again an equation in which you see a logarithm. It's very simple, yes? The name is telling you what it is. Okay, so for example, I say that solve the following equation. Logarithm of x plus 2 is equal to the logarithm of 5 minus x. I want to solve this equation. So it means that find all possible values for x so that the left-hand side becomes equal to the right-hand side. But you tell me, it's very simple. This is the very simple possible case. So what is this one? How can I solve this equation? Logarithm of a number is supposed to be equal to logarithm of another number. Two logarithms with the same bases can be equal. They cannot be equal unless what happens? So for example, logarithm of something in the box is supposed to be equal to logarithm something in the circle. And let us say the base is b. So what happens? If I insist to make them equal, what do?
Square and circle.
You make a square and circle equal. Yes? Because it should be identical to that. So from here, what can I conclude?
X plus 2.
If I want to fix this, I have to fix this. Yes or no? Yes. And if I want to fix this, this is a math 1C problem. I just move x to the other side, it becomes 2x. I move this to the other side, it becomes 3. And then what is x? X is 1.5. Yes? But there is one caveat here, exactly like root equations. It is possible that you also have false roots here. So this is a little bit annoying, I know, but this is what it is. So for root equations, remember, because next week you have the exam, yes? You haven't forgotten that, yes? So root equations, do you remember? We solve the root equations, and sometimes the answer we get is a false root. This can also happen for logarithmic equations. Okay, but is it a false root or not? You don't need to test it. You just need to make sure this doesn't make any problems for any logarithms. What do I mean by that? Because I told you that this is not always defined. This is defined if A is positive, B is positive, and B is not equal to 1. For the base, I do not have any problems at all because I haven't written the base, so it means that the base is 10. So automatically it is positive and it is not equal to 1. So I don't need to be worried about these two cases for this equation. What I need to be worried about is what is appearing in front of the logs. X plus 2 appears in front of this log, 5 minus x appears in front of that log. Do you think that this is a problematic number here? No, because if x is 1.5, I put it here, it becomes 3.5, which is positive and acceptable. And when I put it here, it is 3.5, that's acceptable. So that is not a false root, but you have to be observant about this point. So I would give you examples. Then sometimes the equation that you solve, the answer that you get is a false root. So you have to indicate that, no, this is not the answer, this is a false root. Yes? Is that understandable? Okay. So let me ask you another question. So that is one type of logarithmic equations, which is very simple, I think, because you immediately see, don't say, some people say that I cancel logs, even though it works, but that is not a good story, because log is not a number. Yes, I cannot say I divide by log, logs are gone. But what I did looks like as if I canceled logs. Yes? Okay. But what do you think about this equation? So, for example, let me write this log here. Let me make it for the time being simple. I put a 2 here, an x here, and then I write logarithm of, let us say, 5x minus 6. We want to solve this equation. Okay, so it is not as before, because there is a 2, unfortunately, here. If the 2 was not there, the problems are still the same. What do you say if the 2 is not here? How do you solve the problem? Logarithm of x is supposed to be equal to the logarithm of 5x minus 6. What do you write then? X equals to 5x minus 6 and solve it. But now, this is not the case because I have the 2 here. Yes?
You write x squared equals to...
Yes. So this is why I told you, remember those formulas. It is better to have them in your memory. Otherwise, every time you have to look at the formula sheet. That's up to you, of course. So this 2 is a problem for me. I don't like it to be here. So I told you that there is a way to get rid of that 2, and that is using the formula. So what should I do? I can get rid of it. Of course, the best way of getting rid of it is just erasing it. But of course, your points will also be erased by your teacher. That's not a good idea. So then you have to get rid of it in some way. So how do you do that? According to the formulas, I can get rid of this 2 by putting it up there. Yes? And then it becomes logarithm of 5x minus 6. And now, how should I continue? The problem is exactly as the previous case now. Yes, so what can I do? Again, don't think that I am dividing by log. That is not a good story. It is one of those false stories which gives you good results. Yes, but this is not good. I mean, you shouldn't be happy about doing something fake, you know. So x squared is 5x minus 6. And then you solve this equation. And this is something that you have the exam next week. This is the simplest possible quadratic equation. So how should I solve it? I move it to the left by changing the signs. It depends if you want to use PQ or ABC formula. So let me use ABC formula because you have the exam next week. Let me review things a little bit. So A is 1, B is minus 5, C is 6. I calculate D. Do you remember discriminants by the formula B squared minus 4AC? So B squared is 25 minus 4 times this times that is 24. So it becomes 1. 1 is positive, so I have 2 roots. X becomes minus B plus or minus the square root of D over 2A. These formulas are in the formula sheet, so don't worry about them. So this becomes minus B, which is 5, plus or minus a square root of D. D is 1. A square root of 1 is 1 divided by 2 times A is 2. So I have 2 roots, yes? 5 plus 1, 3 divided by 2 is? No, 5 plus 1, 6 divided by 2, 3. 5 minus 1, 2 divided, so it becomes 2. 5 minus 1 is 4 divided by 2. But be careful. It doesn't mean both of them are acceptable. You have to be careful, and not here. You have to go back to the first and the original problem. Do I have any problems with 3? How many logarithms you see? 2. You have to be careful about both of them. 3 does not make any problem for me here because it is positive. Does it make a problem here? No. 5 times 3 is 15. 15 minus 6 is still positive. So this is not a fake root. It's accepted. So what about 2? No, 2 doesn't impose any problems either, yes? Because if I put 2 here, 2 is positive, acceptable. 5 times 2 is 10 minus 6 is positive again. So I don't have any problems with any one of them. So both of them are acceptable, and these are the solutions of my problem.
Why do I have to go all the way back? Why can't I go to the log?
No, you cannot, because that's exactly the same point, you know? This equation and this equation are not the same. Yes? Because you know, whenever I wrote this, let me tell you something. It's a, so if you see this, to be honest, I mean, if you see this is true or false?
True.
It is false in general. Why? Because, for example, if I choose x to be minus 2, when you see this is equal to this, it means this is always equal to this. If it is sometimes equal, sometimes not equal, you don't say this is true, you say it is false. Yes? Okay, x equals to 2, x equals to minus 2. What is the right-hand side if x is minus 2? I put minus 2 here, minus 2 to power 2 is positive 4, so this becomes logarithm of 4. But if I put minus 2 there, it becomes 2 logarithm of minus 2. But logarithm of minus 2 is not defined in the first place, so it doesn't make any sense. So that is why, you remember, when I wrote the formulas, I wrote a lot of things before writing the formula. Under those circumstances, the formulas are correct. So this formula, when I wrote the formula for you, if you remember, I wrote this formula for you, something like this. I said P goes there. Okay, this is the way that I memorize the formulas, but I respect that this is not always true. It is true if x is positive, b is positive, b is not equal to 1, and p is any real number. If you go back and check the formula I wrote down for you, I wrote a lot of things before start writing the formula. Yeah? So that is the reason. These formulas are valid if you respect the conditions. If you don't respect the conditions, that's not valid. So when I write this, when I go back from here to here, I am automatically thinking that x is positive. Okay? So be careful about that. So it is better, it's always good to go back to the first and the starting equation, not to the middle equation. Because if you take them, for example, and put them here, it always works. Yes? So the false root happens if you go back to the very, very beginning equation. Any questions? Okay, so let me give you some examples. So now the topic is clear now. We want to solve either exponential or logarithmic equations, yes? And we can increase the level of difficulty little by little. Okay. So let me see what can we do here. Okay, so let me write something and ask your opinion about it, and then of course I will give you some points. So let us concentrate on logarithmic equations. After we learn them, I go back and solve more, a little bit harder exponential equations as well. So what do you think I will do for solving this equation? So let me write the example, okay? Example, solve the following equations. Okay, so number one, logarithm of 10 minus x, and then I have minus logarithm of x plus 2 is equal to logarithm of 2. Okay, so we want to solve this equation. Any opinion? Of course, this is why I'm saying that try to change your habit. You don't remember formulas that much. It's not very good. I mean, these formulas are not too much for your brain. Otherwise, you really get confused. Do you remember any formula connecting this? Because if you don't, of course, the formula sheet will be in front of you. But this is, in my opinion, it is not as efficient as having them in your memory. So do you remember? There are two important formulas in logarithm. What are they? We discovered them.
You can use like division.
Exactly. So there are two main important things. Do you remember logarithm of x multiplied by y happens to be what? Logarithm of x, logarithm of y, but added, yes? So it becomes logarithm of x plus logarithm of y. It depends. Sometimes you need to go in this direction. Sometimes it is useful to go in backward direction. It depends on the problem that you're working on. And then there was something similar to this word for division. We learned this one yesterday. This one we learned and reviewed. This one we learned before the break and reviewed yesterday, but this one we just learned yesterday. What was the formula? Logarithm of the numerator minus logarithm of the denominator. Of course, I wrote it in base 10, but you can write it in any base that you like. Any possible base. Yes? So now, again, remember it in both directions. Even if you want to use the formula sheets, remember, sometimes it is useful to go from left to right. Sometimes it is useful to go from right to left, depending on which type of problem you're solving. Yes? So what do you think I will do here?
10 minus x.
So this is two logarithms subtracted. So I can use this formula in which direction? From right to left. But the base is 10 here, so it is not written. Okay, so what I can do, I can write 1 log. I am collecting it back to 1 log. So it becomes what? 10 minus x and x plus 2. So the left-hand side can be combined into one single log. Okay? And then on the right hand side there is nothing I can do, and I don't need to do anything because that is good enough. Again, what can I conclude now? I want to force this log to be equal to this log. So what can I do? So this is playing the role of that box up there, do you remember? Yes, and this is playing the role of that circle. So I want to make the log of the box equal to the log of the circle. So it means what? It means 10 minus x over x plus 2 is equal to, and then I solve this, yes.
What is that square number called again? The one beside on the right side of a log.
What?
What is the number on
This?
yeah, that one, or like in
10?
general, a number to the right of a log. Like there are two numbers.
There is no name for it. We can call it argument.
Argument.
So if it's like a function, so if when you say f of x, this can call the input or the argument. Yeah, that's if this, I understand what you mean. So you say that what we can call this, yes? That's a good question. I can check. We can ask ChatGPT. I don't remember the name. But for example, if I have b to the x, b is called the base, x is called the exponent. But for logarithm, it's a good question. This is still called the base, but I don't know what that is called. Yes? You can check it later. Thank you. Okay, but now 10, this is understandable for everyone. Okay, then how should I solve the problem? So multiply by the denominator. Remember this fact as well. This is also very handy, you know, if you have a fraction equal to another fraction. So American calls it the product of extremes is equal to the product of means. I was thinking why this is the name. Why do you think it's the name? Because when you multiply that, it becomes AD is equal to BC, yes? And then when you write English alphabet, you write them in order. These are called extremes, extreme cases. These are called the mean case, the middle cases. So they call it the product of extremes is equal to the product of mean, okay? Anyway. So this is very handy. I mean, if you have two fractions equal, it's always better to use this very fast, yes? This multiplied by that should match with this one multiplied by that one, okay? So I will do the same thing. What is the denominator here? You don't see? There is an invisible denominator here. I'm using your phrase now, yes? So there's an invisible denominator here, that's 1. So what we do, we say this multiplied by that should be equal to this multiplied by that, yes? Agree? And then you solve the problem. So it becomes 2x plus 4 is equal to 10 minus x. I move this x to the other side, it becomes 3x. I move 4 to the other side, it becomes 6. So what is x then? X is 2. But don't put it in a box yet, because it might be a false root. Where do you go to check it out? You go backward. Do I have any problems with that too? How many logarithms I need to check? Only 2, because that is, of course, correct. So if I put 2 here, I don't face any problems. If I put 2 here, I don't face any problems because both of them, this one becomes 8, 8 is positive. This one becomes 4, 4 is positive. So that is not a false root, and that's acceptable. Yes, so x should be equal to 2. Yes. Okay, another way to solve this, can you see, might be, so can you use this formula to solve that problem? I used this formula, which was very suitable for this case. But can you, if I insist, of course, this is the most natural way to do it, I think. But if I insist as your teacher, and you want to respect me, if I insist you to use this formula to solve the same problem, what is your suggestion? I'm training your brain. We don't have to do it. That is enough. If you're right, you get the full points. So, what do you, yes?
You multiply the left-hand side with the minus. Right?
No, but okay, that's not working. Do you see why? Because if you multiply by minus, you are right. This becomes positive, but unfortunately, this becomes negative.
Yeah.
Yes. So again, you have to use the division formula. Yes. But if I insist you to use the product formula, you cannot use product formula in this form. Yes.
You can move the.
Move. Thank you. Yeah. So you move this one to the other side. Yes. So you can say that, okay, I have the logarithm of 10 minus x. what do? I have logarithm of 2 up there, and then I move the one with negative sign to the right, it becomes positive. But now I can copy and paste this one, but what can I do here now? This is addition, so I write log, but what do I do? This time I, what? Multiply. Multiply it here, it becomes what? 2x plus, and then 10 minus x is equal to 2x plus 4, and that is exactly the equation. Okay, we can continue. So it becomes minus 3x is equal to minus 6, x becomes 2 again. Okay, one of them is enough. You don't have to do it in 2 different ways. Okay, what I will do, I will write one weight for you, okay? So let me write one. Any questions so far? Am I going fast or not? I think it's very simple. Okay, so let me write one for you, wait for you, and go to harder ones. This question. Logarithm of x plus, let me change the base because they are always writing with base 10. That's not a good idea. Let me choose base 2 this time, and I want to wait for you again. So logarithm of x plus 3 to the base 2. I hope that I'm not spoiling the problem. S to the base 2 again, minus logarithm of x to the base 2 is equal to 3 logarithm of 2 to the base 2. Okay, I will wait for it. Sorry, if you don't mind, let me change it to 5. Because, yes, that's better. It doesn't mean you couldn't solve that one, but I want to solve this one. So what are the answers?
9 and minus 1.
Minus 1 you say is a falsehood. Okay, we check it. Anyone else?
Yeah, I also got no.
Yes. So you might have made a mistake, or they have made a mistake. I don't know. Let us check. Okay, so let us solve it together. What is your proposal? I mean, there is not a single way to solve the problem, you know. So how should we solve that? So let us ask Omar. Yes. What do you say?
Look, can you move the log? No, that one.
That one?
No,
That one?
Yes, that one. There's some.
Okay. Why? What is the point of doing that? Yes, there is because you. Okay. Let us follow you.
I want to do with division.
Okay, but what do you do with 3 then?
Move it
Up to the yes, that's correct. So you want to do division.
exactly.
Yes. So it is working. Okay. So let us do that. You are right. So what he is saying is that, so but Omar, if you don't mind, let us use this one. This is easier to move, yes? When you want to move something, you move the light ones, not heavy ones, yes? So I will move this one to the other side. But of course, then I have to solve it using product, because that becomes positive. When I move this to the other side, that also becomes positive. So let us do that. So what you are saying is that logarithm of x plus 3 base 5 plus logarithm of x minus 3 base 5. So you move this to the other side, it becomes logarithm of x to the base 5 and plus 3 logarithm of 2 to the base 5. Yes? But what can I write here? I can write 1 log of 5, but the price is to multiply them. Be careful. This is addition. It turns into multiplication. So it becomes x plus 3, x minus 3. Yeah, it doesn't hurt if you put another bigger bracket. It's not necessary, but let us put it there.
Why?
Huh?
Why?
Because that's a good question, you know. Because usually when you write, it's not a matter of confusion. Yeah, let us not. Okay. But then be careful, because sometimes it is possible we say like this. Yes, then it means whatever logarithm x is, you have to multiply just by y. But here we don't mean this. We mean what? We mean we multiply x and y first and take the log. So that's why sometimes it is not bad to put that pair of brackets there. Anyway, so if you are not confused, write it like this. If you are confused, put another pair of brackets. But can you remember the lesson yesterday? You can do it step by step, but I told you how to do it fast. So what can you do? This 3 should go up there. It becomes 2 to the 3, becomes 8. And then, so this is nothing except log of 8 to the base 5. And then I have log and log added. So what can I do again? I can write 1 log of 5 and then multiply x by 8 becomes 8x. And now be careful. Can I get rid of logs? Yes, because the bases are the same. Be careful. If the bases are not the same, you are not allowed to get rid of them. But here we can get rid of them. So this becomes x plus 3. By the way, x plus 3 times x minus 3 is which rule? You have the exam next week. Conjugate rule. So it becomes x squared minus 9 is equal to 8x. Yes. And then this is a very simple quadratic equation. So you move it to the left. And then you use ABC formula, for example. Or here, PQ formula is also very good, because not only this is 1, but this is even. So whenever this is 1, this is even, PQ formula is better. Okay? So what do? The formula is minus P over 2 plus or minus the square root of P over 2 to the power of 2 minus Q. This is the PQ formula. So you have it in the formula sheet. So it becomes what? X is minus P, which is 8 divided by 2 is 4, plus or minus 4 to power 2, 16, minus Q. So, sorry, minus Q. Q is minus 9. So it becomes 4 plus or minus 25. The square root of 25 is 5. So we get two answers, as Hasbulat said. So it is 9 and minus 1. But be careful here. You shouldn't accept both of them. You have to go back to the original equation. And then you immediately see that minus 1 is problematic. Why? Because of this logarithm and that logarithm. So minus 1 is a false root. But 9, is it 9 a false as well? No, because 9 doesn't have any problems here. It becomes 12 positive, 6 positive, 9 positive. So yes, this is an acceptable solution. Any questions? So it was possible. Yes? But could you write the left-hand side in one stroke instead of doing it step by step? Can you see an alternative way to do it? If I want to do it myself, I do it a little bit faster. Can you see? Can you combine the left-hand side into one log immediately without doing it step by step? We discussed this before. Do you remember? I give you some example like this. If you remember, 2 logarithm of A plus 3 logarithm of B minus 2 logarithm of C minus 7 logarithm of D. If I ask you to combine them in one go, not step by step. Do you remember? We had this yesterday. So what can I do? If I want to write it as one log, I just write log. You know that this 2 will go up there, this 3 will go up there, this 2 will go up there, this 7 will go up there. But this is an addition. It means this will be multiplied, but this is negative and this is negative, so it will be divided. So what should I write in one go? A to the 2 multiplied by B to the 3. Because of negative, it goes to the denominator. C to the 2, D to the 7. Okay, so this is good to remember. I mean, otherwise it takes ages. So here, can you tell me how to combine this, like I told you there, in one step? So you write one log of 5, and then this and that should be multiplied. So it becomes x plus 3, x minus 3, but this one, because of this negative sign, will go to the denominator. Yes? And the right hand side, I immediately write it logarithm of 8 to the base 5. And then this is the same story. So then you say that this one and that one are equal. So if you solve this one in this way, that's also possible. It doesn't matter which one you use, but whatever you do, if it is possible to do it correctly, that's good. That is acceptable. Okay, let me give you another equation. Yes. No, this is division. This is multiplication, but this is division. So the ones with negative coefficient, they all go to the denominator. The one with positive will go to the numerator. No, okay, let me do it step by step. If I want to do it step by step, it takes a longer time, but it works. So first of all, you have to write this like that. The next one is plus logarithm of b to the power of 3. The next one is minus logarithm of c to the power of 2. The next one is minus logarithm of d to the power 7. Yes? Now, here I can write logarithm of a2 multiplied by b3. Yes, but between these two, I have to first take a minus sign out and then write it as logarithm of c squared plus logarithm of d7, because this minus sign is both for this one and that one. So this becomes logarithm of a2 times b3 minus, this is addition, this is multiplication again. So it becomes c2 dot c7. But now this is the only negative sign involved, so it becomes logarithm of a fraction. a2 b cubed goes to the numerator, c2 d7 goes to the denominator. But I want you to avoid all these writings, yes, to be able to do it faster. Yes.
If you're going from left to right, why are you not just doing the multiplication, then you divide by c squared, and then you divide by d7? Because you divide what? Because
you can do that, but then of course it becomes ugly, you know. It becomes a squared b cubed divided by c squared divided by d7. But that's the same thing.
Oh, it is?
Yes, because if you give it 1 here, this will go here, this will go. But this is much uglier than this one. Because if you have more negatives, then you will divide by another one, divide by another one, yes? Okay. Anyway, so now I want to give you another question and wait for you again. Okay, so this one, logarithm of x to the base 3, and then you have plus logarithm of x to the base 5. You see, this is the first time that the bases are not the same, is equal to the logarithm of 225 to the base 3. If you need some calculations with your calculator, you can do that. But of course, this is not something that you get exact. When I ask you solve equation, I always mean find the exact value unless I mention it explicitly not to do so.
Robert,
Yes, please.
should you do the first log x over 3 to the other side?
Okay, don't spoil the problem for everyone. Just solve it and give me your answer. Yes. Yes. I didn't expect that this becomes a hard problem. Sorry for that, but if you want, we can wait a little bit, you know. Okay, I mean, if you are interested, I will solve it for you, but this is a very hard problem. Okay, so just leave it and solve another hard problem. This is a little bit more realistic. So this equation, I want you to solve logarithm of x plus 6, and then I have minus a half logarithm of 2x minus 3 equals to 2 minus logarithm of 25. 2 minus logarithm of 25. Yes, yeah, I mean, This is, I will solve both of them for you, but that is also very hard. This is, I would say that this is much harder than A-level questions in the book as well. But here you have to be very creative. Okay, let us do it together because I think they are unreasonably hard. Okay. So I want to hear from you. Let us say that I want to find this. What is your suggestion for me?
You can try to add the logs on the left side by moving minus 1 over 2 over to the argument, and then you multiply the entire argument of the first log with the argument of the second log.
Not multiply. Because that's you say that I move minus 1/2 up there, then multiply. Minus 1/2 is not good. So because then you have to work with negative powers. I prefer to work with positive powers. Of course, if you manage to do that, that's okay. That's working. But what Hasbulla is saying, I think is good, you know, because you know that this number is a little bit annoying. Because if this number wasn't there, then this is just a simple formula. Yes? But this 1/2 is there. So it motivates me to get rid of this 1/2 somehow. Yes? So what do? I will take this 1/2 and put it up here. Yes? So you see, even though this problem is hard, but it is not that hard that you don't know where to start from. Yes? So this becomes minus logarithm and 2x minus 3 to the power of 1/2. For the time being, you might not know what to do with the right-hand side. Don't worry, just copy and paste it, okay? Okay. Understandable for everyone. And I am saying that that is not only understandable, but it is natural. Because if I want to use the formula of the subtraction of 2 logs, this is an obstacle in front of me. I have to get rid of it. Okay. But usually in mathematics, this is a little bit weird combination. We have it in a more familiar symbol. So can you tell me, how can I write this in a little bit more familiar way of writing?
1 over.
No, not 1 over. A square root. So it is a square root of what? 2x minus 3. Yes? So we are making it more familiar to our eyes, yes? So I would write this, and instead of that one, it becomes what? Square root of 2x minus 3. Okay? And now I will give you a hint. What do you think I can do with these 2 there? Because 2 is also a problem here, you know? Because if this 2 is not there, the problem is then not hard. It's very simple, because you know that this becomes 1 log, then you have only 1 log, and then you can get rid of logs and then solve the problem. So this 2 is a little bit problem here as well. But I cannot put it up there, because this is not 2 times log of 25. It is 2 minus log of 25. So how can you think I can get rid of that 2? Anyone else? How can I get rid of that 2? This is, we haven't talked about that. You know it, but I haven't solved any problem like this before. So I want to see if you can come up with the creative part yourself. So what did you want to say?
Maybe you can do 10 to the power of log 2 base 10.
Yes, but is it useful? Then it becomes 2 to some power of with log and minus another log. The idea is not bad, but you did it not very effective. Write 2 as a log. What log is that? Of course, this is a lot of logs you can write. The answer is 2.
Log 2 or log 4 with base 10.
Okay, yes, that is correct. But this is not useful. Why is not useful? So what Ismail said is correct, because log of 4 to the base 2 is exactly 2. You are right. So if I clean this and write that, that is not wrong, but it is not useful. Why? Because then I will have a log whose base is 10, and then I will have another log whose base is 2. There are no formulas there. Yes, Nicole?
Yeah, I was going to say that you want to write the log with the base
10, which becomes 2. What is that log?
100.
100. Log of 100 is what? 2. Because 10 to power 2 is 100. So remember this trick in your toolbox. So you write log of what? 100 minus log of 25. I hope that you see the problem is more or less solved. Or at least it is, we are hopeful we can solve it. Why? Because first of all, any questions so far, I told you that putting 1/2 up there is not hard to understand. Because I want to use the formula for subtraction. The formula for subtraction doesn't have this there. But when I have it, there is only one natural way to think is to get rid of it. One good way is to clean it, because I told you it is not possible in mathematics. So there's only one way to put it up there. And then when I put it up there, I really want you to remember this formula. This is this one. So which one is more suitable for our eyes? I prefer this one. I don't know about you. I prefer to write square root of the box instead of putting a 1/2 there. So when this happens, I write it in this form. So I have done more or less nothing so far. The only part that I was a little bit creative is how to get rid of this 2. So Ismail proposed this one. This is correct but not useful. But then he corrected himself. This is not only correct, but it is also useful. Because I was able to write 2 in the log whose base is the same as log here. Now, can you tell me, is this the division formula or not? It is the difference of 2 logs. What can I write? I can write the log of, tell me, x plus 6 divided by the square root of 2x minus 3. What can I write for the second one? Can I write it the same? I can write 1 log of 100 divided by 25. Is that right or not? Can I get rid of logs now? Yes, I have a log of something equal to log of something else. So I can get rid of the logs. But there is a better name for 100 over 25, which is 4. So this is nothing except 4. So what happens? This means that this expression is equal to what? That expression is equal to 4. And now this is something very interesting. You see, x plus 6 is equal to square root of 2x minus 3 is equal to what? 4. But what is this equation called? What is the name of these kinds of equations? Root equations. So for example, next week I can give you these two for the exam, because that's a root equation. So what we did, we didn't solve the problem yet. We changed the logarithmic equation to a root equation. And now we have to forget about logarithmic equation, review what we learned about root equations. So let us review, because that might be in your exam next week. How can I solve this? Do you remember what was the general strategy to tackle root equations? No, to get rid of the third sign. Yes, by raising to appropriate power. But there was a problem there. Sometimes if you just naively raise to power, you not only make the problem simple, you make it harder. Yes. So here, what I do, can I use this American rule of the product of means equal to the product of extremes here? Yes, because there is an invisible here, fraction. So I would say 4 times that is 1 times that. Okay. So if I give this next week in the exam, this is not E-level question, but this is not A-level question. This is C-level question. So next exam, next Tuesday, I might give you this and I ask you to solve it under the C-level question. So how can I solve this?
Divide by 4.
Not divide. Because if you divide, of course it is not wrong if you divide and you manage to do it. But I prefer not to divide. I raise it to power 2. So it becomes 4. The important thing, I don't know, are you studying or you want to cramp everything on Monday? It doesn't work. You have to start studying from now. Okay? So I have to raise it to power 2. But this is a product. Raised to power 2, it becomes 16 This one to power 2 is 2x minus 3. This one to power 2 is what? X squared, 2 times the first one times the second one, plus the second one squared. Yes? And I multiply 16 in, 32x minus 48 is equal to x squared plus 12x plus 36. Yes? And then you know what is this? It is a quadratic equation. So x squared, I move 32x to the other side. It becomes minus 32 plus 12 is minus 20. I move this to the other side. It becomes how much? 84. Of course, if the numbers are so big, I will allow you to use calculator. Yes? So don't worry about the numbers here. But this, I feel, I don't know, might be I'm wrong. I feel that you don't remember these things. Do you remember? Don't let everything for the next week. Yes? So you have to start from now in order to succeed the next week exam. How many of you are feeling good about this? Understandable?
Yes.
Okay. Yes. Hopefully you're right. Okay, so I want to solve this equation now. So don't get confused. We started from there. Of course, on Friday and on Monday we practice on the exam, but it doesn't mean that you shouldn't study. You have to study at home a lot. Okay. So how should I solve the problem? Let me use no. I can use PQ formula because this is already 1 and the middle one is even. Whenever this happens, PQ is better. So what is the formula? Is minus P over 2 plus or minus the square root of P over 2 squared minus Q. So P is what? Is minus 20. Minus 20 minus, it becomes positive 20 divided by 210. Okay, plus or minus 10 to power 2 is 100 minus Q. It's, by the way, you see, you don't need calculators at all. It is simple, yes? So it becomes 16. But what is square root of 16? Hopefully everyone knows is 4. So I get 2 roots. What? 14. 1. What? 6. Okay, but do you remember? I told you that one of them still might not be true because root equations also have false roots. And if I confirm that this is not a false root for the root equation, it might be a false root for the log equation. So you have to be careful. Yes? So that's why I'm saying it's a hard problem. So do you think 6 is a false root for the root equation? Yes? Can you calculate it in your head? 6 plus 6 is 12, remember? 2 times 6 is 12 minus 3, 9. Square root of 9 is 3. What was that? 12. 12 over 3 is 4. That's correct. So 6 is a correct answer for the root equation. Is it also a correct answer for the log equation? Yes. If I put 6 here, I don't face any problems. It becomes positive. If I put 6 here, it is still positive. So finally, 6 is one answer to my original problem. What about 14? If I put 14 here, it becomes 20. If I put 14 here, 28 minus 3 is 25. Square root of 25 is 5. That's also correct. 20 over 5 is 4. But is 14 makes a problem for logarithmic equation? No. The problem is finished. So, of course, this is really above the level of the book. But it was not hard. Okay? Yes. So the logarithmic equations in your book are much, much simpler than those. Okay, so that's it. Today's lesson is more or less finished. But there is one problem on the board left. I want to stop recording now and give you time if you want, or we can start solving it together. Let us do it together. Do you have any opinion here? Okay, I want you to tell me. I will try what you say. If it doesn't work, just clean it and do it again. That is exactly what I did when I was at your age, and I still do when I am solving harder problems. So that is the only way if you want to learn mathematics in an efficient way. Okay, I want to hear from you. The only bad problem in front of us is what? One of them is base 5, two of them are base 3. What is your opinion? Yes.
So 3 to the power of log 3, 5 is 5. So we can write that instead of 5.
Okay, so what did you say? Can you repeat it?
3
3.
is equal to log, no, 5 is equal to 3 to the power of log 3, 5.
5, 3.
Yes.
Yes. Okay, this we can do that, but is it useful?
Yeah.
The responsibility is on you. So you are saying that change this 5 to that very complicated expression? Okay. So by the way, there is one principle to be a mathematician, and what is that? To be lazy. I told you laziness is a very good thing for humans. And the reason, for example, you have car is because you are lazy. The reason that you have computer, you are lazy, yes? Because you are lazy, you start thinking that, what can I do? If you are not lazy, then you will start, okay. So what do you think will happen, okay? No miracles will happen. Okay, either you imagine, if you are not good in imagination, then you have to write some horrible things like this. I don't say this is horrible. Might be you can find a way out of it.
And now you see 3 in the middle one. We can take the log 3, 5 and put it in front of the first one. 1 divided
Here?
So 1 divided by log 3, 5.
Yes. Okay, that is what you are telling me is correct. Okay, so I don't know how many of you remember, we had two formulas. I told you one of them is not in the book, so I mentioned it with 5 prime, yes? So one of them is that if I have P up there, what can I do? P goes back directly, yes? But I told you that there is an extra formula. What happens is P is up there, yes? So what happens if P is up there? It doesn't go back directly, it will be 1 over P and goes back. So you are using this. Then you will face another problem. So that's very good. That's very good, to be honest. So then you are taking this and you want to put it back, and then you have to reverse it. But then when you reverse it, something like this happens. Yes? Okay? Something like this happens. I agree. What you have done is completely correct. If I see it, I still read it to see what you are doing. Okay, so what do you do now? So he managed to make all the bases the same. Very good, actually. Yes? But what do you think now I will do? Hmm? Can you see what we can do? I don't know. I am following you, so I was hoping that you tell me something. So let me write it a little bit more clear. So what Ismail did, first of all, everyone agrees with what he wrote here. Yes? This is very elementary. 3 to the log 5, 3 is 5. So he said to me, take this innocent 5, make it much complicated. Okay? So I did. And then he told me that we had a formula that I called it 5 prime yesterday. This P doesn't go directly to the back. It becomes 1 over P and goes to the back. Yes? So yes, this is playing the role of P. I write 1 over P and moved it to the back. If you want, I can write it a little bit more clear so that you can concentrate to see what happens. Now we have this scenario. We have this scenario. Do you see now what to do yourself? Yes?
To get rid of 1 over log 3, 5, can we multiply by log 3, 5?
If you do that, then yes, you can do that. You can write log of 3 over 5, 3 to the 5, but then 5 becomes another base. You did all these gymnastics to get rid of that base, yes? But there is still a way. What can I do with this one? You see, this is why you don't become a good mathematician. If I can teach you this, then you become very good. If I write this, and I put my proverbial gun in your head and say, do something, otherwise I will kill you, what do you do? Put 1/2 where? On the x. But ask yourself, you answer this immediately under 1 second. But that is the same thing, but you don't answer it. My role as a teacher is draw to your attention to it. Because you knew the rule. If you didn't know the rule, you didn't answer this one. You told me immediately that I can write it as this, yes? Why do you think 1 is the same? Instead of 2, I have a little bit weird number, and then I have log of x to the base 3. When I say what I can do with this one, you get stopped. Isn't it exactly the same problem? But instead of having a very friendly number 2, you have a weird number, but that is also a number. So what can I write here? I can write log again, and then I write x to the power of what? Tell me. 1 over, exactly, logarithm of 5 to the base 3 and then base 3. Is that understandable? Yeah. So that's the same story. Okay, but it doesn't mean it is good, but it is one possible way. Let us do it and see what happens. So I can write log of 3 x to the power. Let me write it very small so that you don't get confused. So that is the scenario that I have now. Yes. By the way, Ismail, it worked. I realize now it works. Can you tell me how?
Can we make multiplication?
Yes, we can do the multiplication now. Because this is a log of a very simple thing. This is the log to the same base of something more complicated. But who cares? This is something. So can I write this as log with base 3 and then multiply this by this, yes, whatever it is. Don't let this distract you. This is a number. Who cares? And then I have what? Yes or no? Okay, but one step further at least you can go. What is that step?
225
This is log 3 of something. This is log 3 of 225. They are supposed to be equal. This cannot happen unless whatever this thing is, it should be 225. So it becomes x times x to the power of 1 over log of 5 to the base 3 is 225. Yes? Yes or no? Okay. So at least I would say that this is a progress. To be honest, I didn't think that this will work, but it worked. Yes? I would say this is a progress. Why? Because my original equation was that equation. Now I have this equation. I consider this a little bit simpler than that equation. But let me ask your opinion. You can solve it now. Okay, we have 5 minutes. Let us finalize this beautiful problem. Okay? So, can you tell me, I think Ismail told me something in the middle of the way. 1 over logarithm of 5 to the base 3 can be written much simpler now. Not much simpler, a little bit simpler. You remember we told you today, logarithm of 5 to the base 3 can be written as logarithm of 5 divided by logarithm of 3. If I ask you what is logarithm of 3 to the base 5, what is the answer? It is logarithm of 3 divided by logarithm of 5. Do you agree? So this means that these two numbers are reciprocal of one another. So if I write 1 over logarithm of 5 to the base 3, what can you write in front?
1 over.
Now 1 over logarithm of 5 over 3 is logarithm 3 base 5. Yes? Do you see why? Because this number is this number is the other way around. Okay, so that's a very handy formula and a very strange formula, you know. Very beautiful. Yes? If someone asks you why this formula is correct, this is important to be able to tell. Yes? It's a very nice formula. If you write 1, you're allowed to switch these two. So what can I do now? I can write x times. So tell me, what can I write instead of this? The base is x. Instead of writing 1 over log of 5 to the base 3, what can I write?
Log base 3. Log
Yes, log 3 base 5 is what? Agree?
Yeah.
But can you tell me what can I write for the left side? You see?
1 plus log.
Yes, thank you. So you are learning. Because you see, I am sure that how many of you cannot answer this question? What is the answer to this? 3. How did you do that? You add 1 to 2. But is it the same question? Again, the same question, but instead of a friendly number 2, I have a stranger number, yes? Anyway, the rule is the same, so it becomes x to the power of what? 1 plus logarithm of 3, 5 is equal to 225. Yes? Okay. But now I want to see how many of you can find my x. It's still a hard problem. I can say that this is a level 3 problem even from here. Okay, so there is no time. I don't want to spoil it. I want to give you time. I will solve it tomorrow for you. I really want you, if you are interested. I mean, if I was at your age, I couldn't sleep before solving the problem. That's exactly the attitude. So if you can sleep very good, so it means that you're not liking mathematics that much. Something in you shouldn't let you sleep before solving the problem, okay? So go home and try to solve the problem. I am not saying this is the only way. Ismail told me something, I followed him, and I think that this is good, because I think we can solve this problem. Okay? I want to see how many of you can, in principle, solve this problem. I want you to find x. It is not obvious what x is. Okay, thank you.